Hello, this is 48D. If you have a question on 48D, what I would suggest that you do is, after you watch this video here, is I would suggest that you go back and look at the very end of this week's module and make sure that you know the technology corners for today's test, because this is definitely one of those ones that you want to be able to do. Now, there's two ways to find regression lines. One was using the formula for slope. Slope is equal to r times s sub y over s sub x, and then you plug it in and solve it like it's y equal mx plus b, where the points that you use, you might, if you're given the mean of your explanatory and response variable, then you plug that in and solve it just like it's y equal mx plus b. And there's an example of that in the book. I'd be happy to do that, or a question like that if you have a question. I did one yesterday during our Zoom meeting. But this one gives you data. And when you're given data, you can always find the regression line to solve that answer. Now, the question was 48 part D, calculate and interpret the residual for a woman who had a lean body mass of 50.6 and metabolic rate of 1502. Earlier in the question, they asked you to find the least squares regression line. So I don't think, if your question is only 48D, I just don't think you're going back and using that regression line. But let me quickly run through what you need to do. Go into Stat, go into Edit, enter all those numbers into that. Okay, get out of that. Stat, Calc, and remember it's not 4, it's number 8. Enter, and then it was list 1, list 2, frequency list we don't care about. This story regression equation, if you press vars, yvars, function, enter, that equation will be stored on your calculator. And calculate. Now you should check, do you get the r squared and do you get the r showing up? If not, you have to go into catalog and turn diagnostics on. Okay, again, that's something that I can go through if you need to see in more detail. So our equation of our regression line is y hat, which means that's your regression line. That's what you're going to use to make predictions. 201.16 plus 24.03x. And I want to double check in the book just to make sure that I have that correct. 201.2 to 24.026. So they rounded differently, and rounding doesn't matter for us. Let me go back to that. So that's perfectly fine. Okay, then in part D, it says calculate and interpret the residual for a woman who had a lean body mass of 50.6 and a metabolic rate of 1502. So 50.6. I'm going to write it as a point. Oh, I don't think you can see it. Moving it down a little bit, 50.6. And then 1502 is what I think I saw. Yeah. All right. So this is our observed value. Observed value. Let's figure out what our predicted value was. And that's what we're interested in, is being able to come up with an equation that will allow us to make predictions. So y hat equals 201.16 plus 24.03 times 50.6. Let's see what that does for us. Okay, so I go 201. I can show you. I don't need to keep it hidden. 201.16 plus 24.03 times 50.6. And I get 1417.078. Our predicted value is 1417.078. Okay. So now what I do is I need to find, I think it said find the residual. I keep forgetting the question. Yes, it is. So residual is observed minus predicted value. So observed is 1502. Predicted is 1417.078. And that gives me $84.92. I want to check in the book, and they get 85.1. Close enough. That's close enough. Again, rounding We never make a big deal about rounding. We're in the ballpark. Now, the key thing, this is important too, is the interpretation. So what that means is this woman's actual metabolic rate was 84.92 calories per day higher than predicted based on her lean body mass. Let me say that again. The woman's actual metabolic rate was 84.92 calories per day higher than predicted based on her lean body mass. I will make a big deal, and the College Board makes a big deal about that interpretation. So make sure you have that right. Hope this helps.